Hello, I'm going to kind of quickly go over a few things about what we did in class today. This one we most likely got through, so I'm kind of doing this just as review and for people who maybe missed class. So here was the key. You were supposed to fill yours out ahead of time and then say how many you got right. When I did this for myself personally, that's not the key. Oh, that's not it. That's what I did personally, and I only got one right, so grade yourself. But then one of the things down here is we haven't really talked much about how you know if something's a binomial setting. The most important thing is the n. There's this BINS that you'll see in the book and you'll see in some other places where how I know it's binomial. The main thing is the n. That's n equals 5 because we've got a set number of trials. We're only doing 5 things. There is another thing which is like how many times does Wilt Chamberlain shoot until he makes one, where we're counting how many trials. And that's a different number. And then these other 3 criteria will be the same for both what's called the binomial and the geometric, which is the next worksheet. So to know this is binomial, we have to know that it's a set number of trials. It's super important. We have to know it's binary, which means it's either true or false. We only have kind of one criteria. Either you got it right or you missed it. You made the shot, you missed it. It's an orange skittle or it's not an orange skittle. That's binary. Independent means that from one answer to the next, they don't affect each other. And that's kind of like essentially it means with replacement, but not always. But in this case, certainly, if I get the first one right, there's no reason why I would get the second one right, or vice versa. So this is definitely true. Each one of my things here is independent. And then the S for the BINS stands for same probability for all. And typically when you justify this, you just say, what is the probability of success for each one of the trials? In this case, it's 1/4. So this may come up on a free response where you have to justify why is this binomial or why is this geometric? And you've got to show binary, independent, and same probability. And then depending on whether it's binomial, you need to show set number of trials, or geometric. It is you're counting trials until success. We're gonna keep trying until we succeed is what I like to say, G for geometric. All right, so that's a little review there. The one thing I want to show on this key, so you have all the answers in Google Classroom, but I want to show there was 2 ways to do number 3 here. So if you haven't done number 3 yet, don't look. Figure it out first. But 0.25 squared is me getting 2 right, and 0.75 to the third is me getting 3 wrong. But this is really like getting the first 2 right and getting the next 3 wrong, because there's a bunch of other possibilities here. And so I've listed out, like the first 2 right, first and third, I've listed them all out. There's actually 10 of these. I was just very careful. I got them all. Those are all the possibilities. But this is the really slow way to do things. And if you've got a very large number, it's impossible. So there's actually 10 combinations there, and there's a quick way to find that out. There is a button on your calculator, or if you've got a graphing calculator, if you go to the math function and go over to probability, you'll see this thing called NCR. And that will allow you to put in, I want 5, choose 2. So often this is called choose. I like to call it combinations. But it's 5, choose R, or 5, choose 2. And when I put that in the calculator, it will say 10. And depending on your calculator, you might have to play around with that. But 5, choose 2 should give 10. And if you want to kind of check yourself real quick, if you want to try to do, this was the probability of making 3 out of 8 shots, which we talked about briefly for Wilt Chamberlain. If you do that in your calculator and doing it properly, you should get 56. There are 56 ways to get kind of misses and makes for 8 shots. Is that 8? That's 9. Okay, that's one possibility, but there's 57 others where I make 3 out of 8. That's what that means. Okay, so you need to know that. This rest of this I'm hoping is kind of transparent. There's some shortcuts down here for figuring out expected value that you don't have to add up the whole table. And there's definitely a shortcut that you need to know for figuring out standard deviation. Okay, so look at that carefully. You want to know what those shortcuts are. Okay, so the real reason I'm here is we did not quite get to this other one in class, and now I just have to find it. All right, so supposedly 20% chance of flipping a bottle upright. So if I flip 10 times, we have learned that our expected value is n times p. That was the shortcut we learned on the other worksheet. So 10 trials, probability is 20.2, that is 2, which makes sense. If there's a 20% chance of flipping it upright, and I do 10 times, you'd expect, well, you're probably going to get 2 times. Sometimes you're going to get more, sometimes you get less, but over the long term, I'd expect to get 2 for every 10. That's what expected value means. If I did many, many trials, that's how many I would expect out of 10 in general. Probability that he makes exactly 2 flips, okay? So 0.2 squared is making 2, and 0.8 to the 8th is missing, and this is a very tiny number, because that's not likely to happen, because this really describes me making the first 2 and missing the next 8, essentially. So there are a bunch of combinations of that. So I need to do 10 choose 2. And when I do that in my calculator, and I'm going to show you on these little cheap calculators I've got, even has it. Shift that button below the C there you can see the thing NCR. I hit that, and it gives me the C, and then I realize after playing around with this, I got to put the 10 first. 10, shift, C2, 10 choose 2, and it tells me there are 45 possible combinations where I've got 2 makes and 8 misses. So 45 times whatever 0.2 squared is, times whatever 0.8 squared is, and that is some number that I'm not going to bother to calculate. I will also say, if you type in 10 choose 2 into Google, it should tell you 45. It's smart enough to do that. Less than 2 flips. So less than 2 flips, that is the probability of me making 1 flip, 0 flips, or 1 flip. That is the less than 2, okay? So this probability of x being less than 2 is the probability of x equals 0 plus the probability of x equals 1, which means it is a combination of 10 choose 0. There's only one way that can happen, because it's 0.8 to the 10th. There's only one way I can miss them all. So this is really 1 times 0.8 to the 10th, whatever that is. And then the other one, I'm making 1. So 10 choose 1. It turns out there are 10 different ways. I can make the first one, second one, third one, fourth one, fifth one, sixth one, so forth. That one's easy enough. And then that one is 0.2 to the first, if you want to do it that way, and 0.8 to the 9th, because I'm missing 9 of them. And so whatever 10 times 0.2 times 0.8 to the 9th is, and I add those together, and that's a chance of me doing that. All right, probability that he makes at most 2 flips. So at most means at most 2 flips. He won't make more than 2, but he can make 2. So this is the probability of x is less than or equal to 3 at most, okay? Oh wait, at most 2 flips. Less than 2 flips. That's wrong. This is less than or equal to 2. Less than or equal to 2. I'm going to double check my notes to make sure I'm not telling you stuff that's wrong. Yeah, I got that right. And so this is what we got above, plus we need to add in the 2. So whatever answer I got up there, I'm going to add in choose 10 to, oh, we already got that. It's this answer right here. Whatever answer we got up there, we have to add in to that, okay? So that was the 0.2 squared times 0.8 to the 8th. So I add all those 3 together. And that at most, you got to think about at most and at least. Is that at most 2 means 2 or less. At least 2 would mean 2 or more. Let's see. All right, so here's the new stuff. This was kind of review. Okay. So after the first 10 flips, Michael wants to do 10 more, but his teacher is getting annoyed with all the noise and tells him he must stop flipping the bottle once the bottle lands right side up. So this is saying, hey, we don't know when it's going to land right side up, but he will stop once he succeeds. This is a geometric progression, okay? All right, whereas in the other ones, we knew exactly how many trials we were talking about. Okay, Find the probability that he lands on the first try. Well, that's 0.2. Finds the probability he fails on the first try and lands on the second try. This seems pretty easy. 0.8 times 0.2. Find the probability that he fails the first two and lands on the third. 0.8, and I'm going to be lazy and say to the third, times 0.2. Notice the pattern. Okay? Except not that should be squared. Okay. Find the probability that he fails the first three times. Once again, 0.8 times 0.8 times 0.8, 3 times. And I've talked more than 10 minutes because my lights just went off. Hold on, turn it back on here. All right, I'm almost done. So we can do these probabilities here. Probability of this one right here is just the 0.2. 0.8 times 0.2 is 0.16. I'm going to write that 0.20, 20%. This is 0.128. This is 0.1024. And I can do these so quick because I'm cheating. And then the same thing, this would be 0.8 to the fourth times 0.2 again, which is 0.0819. Notice how these are getting smaller and smaller because that makes sense. The chances get lower as I go further out, as I multiply by more probabilities. And this is why this is actually called geometric. A geometric series is where you multiply the previous one to get to the next one. So essentially every time here I'm multiplying by my failure rate. So another failure, 0.8 to the fifth times the 0.2. Notice in each one of these I'm multiplying by 0.8, 0.8, 0.8, 0.8. That's the geometric progression. I'm going by a factor of 0.8. So what is that? That is 0.0655. Exactly like it is in the sheet you've probably already looked at. Find the probability that he lands on the 10th tries. You write a generic rule for finding the probability that he first lands the bottle in the case flip. So obviously on the 10th try, it's 0.8 to the 9th because he fails 9 times, and do it on 10th. And our generic rule here for probability of x equals the kth trial, which is what they asked. Think about that. We know it's got to be 0.8 with some exponent, and 0.2, which as far as I can tell is always 1, or just leave it like it is. And so this right here is always, that's going to be k minus 1. So if I'm 10th trial, x equals 10, that's going to be a 9. All right. How many flips do you expect it to take for the bottle to land right side up and wide? Now, when I did this, I was just kind of like, well, just adding these up, that seems about 50%, so somewhere in this range. But the shortcut for kind of doing this is whatever the probability is, so in this case it's 0.2. If we take that and we invert it, the mean is equal to 1 over 0.2, or in this case 1 divided by 0.2 is 5, which kind of makes sense. If there's a 20% chance of making it, I would expect if I did this 5 times, I would probably get at least 1. So that's where the 5 comes from. I'm going to pause it there. Make sure you take a look at the notes that you should have on the back. I'll put that there. And then also, if you want to try to check your understanding and check yourself, that would be great. Notice that's a T. I said that's a G. Whatever you want to do, remember, it's not the N. For a binary, we've got a set number of trials. That's an N there. For a geometric, this is something else. Trials, gonna keep trying until I succeed, something like that. And then there is the shortcut for the mean. And we didn't talk about variability, but there's a shortcut for finding the standard deviation. Okay, thanks for watching.